Let's kick off our whirlwind calculus tour with limits. Imagine you're staring at a function, squinting and asking, hey, what are you trying to do as you get closer to this number? Sometimes the function just shrugs and says, I'm not sure either. Limits are all about approaching a value, not necessarily getting there, like when you almost finish your homework, but not quite. This concept sets the stage for everything else in calculus. It's the mathematical equivalent of peeking around the corner to see what's coming next, and sometimes the answer is as mysterious as your future test scores. Ready to move on? Let's see what happens when things start changing. Now let's talk derivatives. Picture this, you're watching your crush walk away and you're desperately tracking how fast they're leaving. That speed, that's a derivative of the rate of change. In math speak, it's written as fx, which basically means how dramatic is this change. Derivatives help us measure how things shift, whether it's the speed of a car, the growth of your bank account or lack thereof, or the way your mood changes during math class. It's all about capturing the action, the movement, the drama. And just like in life, sometimes the change is fast, sometimes it's slow, but it's always happening. Let's see what happens when we reverse the process. Time for integrals. If derivatives are about change, integrals are about collecting all the little pieces to make something big. Think of it as apologizing after you messed up. You're gathering all the tiny moments to make things right. In math, integrals help us find areas, volumes, and even how much pizza you ate yesterday if you kept track. It's the opposite of derivatives. Instead of breaking things down, you're building them up. Integrals are like assembling a puzzle one piece at a time until you see the whole picture. And just when you think you've got it, calculus throws in its biggest twist. Here comes the big reveal, the fundamental theorem of calculus. It's like finding out that derivatives and integrals are actually siblings, always fighting but deeply connected. This theorem tells us that taking a derivative and then an integral or vice versa brings you back to where you started. It's the ultimate plot twist in math, showing that breaking things apart and putting them back together are two sides of the same coin. This connection is what makes calculus so powerful and honestly a little bit magical. Now let's see how all this math actually shows up in real life. But where does all this calculus show up? Pretty much everywhere. In physics, it explains why objects fall besides your grades, of course. In economics, it tracks how fast your money disappears. And in engineering, it makes sure bridges do vibe too much. Calculus is the secret sauce behind how things change, move, and grow in the world around us. It's not just fancy math, it's a toolkit for understanding reality. So next time you wonder why you should pay attention in class, remember, calculus is everywhere, making sense of the chaos, one equation at a time.